Hey guys, so finally after months of waiting for parts, and just a whole bunch of noob mistakes on my own part, we finally have part 2 of the Ebike mod. Let's check it out. So most of our parts are in. We got the LED drivers, got the LEDs, and we got a couple heat sinks. We're still missing an LED, so we're only going to be able to do 2 of these today. So we're going to do the headlights. So one of the things we're going to have to do here is put the heat sinks onto the LEDs. Take a bit of this stuff. I'm going to wipe off the heat sinks. I'm going to wipe off the backs of the LEDs. I'm going to take this heat sink paste and put just a little dab on each. That's probably too much. Just gonna spread it out here. And then I've got to put those together and get them into these brackets. So this is going to require 2 hands, and it's going to be hard to keep in frame, so I'll be back when I get those in there. LED, heatsink, and locking brace. And it's in there solid. So now we have 2 LED headlights. So it's a bit of a mess, but maybe we can make some sense of this. Up here we got the kill switch, which is across the positive now. It's all wrapped up in here. It just cuts off positive power directly from the battery. So then afterwards, here where it gives the power to the motor controller, the large power cable. I've taken the positive 48 and ground, run them through the chassis all the way up to the front. And I am cramped in a corner, so I'll show you that in a second. So up here at the front of the bike, the positive wire comes in here, and the negative wire comes up and goes in. And it's a complete mess now. But up in here is a little board I made with some MOSFETs and a relay on it. And from there, it goes to a little Arduino Pro Mini. So this is going to control my brake lights, my headlights, and taillight. On that little board in there are some NPN transistors. So basically there's going to be power for the taillight, power for the headlight, and then this one's for the taillight. This is the negative wire, which is connected to the transistors on that board. And then, oh actually this is the headlight one. Up here, the gray one I've got wrapped up for now. That is the one for the taillight. The brake wires go down to the Arduino somewhere in here, The Arduino just monitors the brake wires as well as the headlight switch, which is here. And then if the headlights are on, my headlights will be at full brightness and my tail light will be at 75% brightness. So when I pull the brake lever, there will be a noticeable difference from 75% to 100. If the lights are off, when I pull the brake lever, it'll simply turn the backlight on to 100%. So I'm going to finish running the wires for the taillight, which still has not shown up, and I'll get back to you. Alright, so that probably didn't make much sense. Let's take a look at the schematic instead. The last time we left off, we put a step-down module in, and we were able to get 12 volts off our 48 volt battery. 12 volts can be useful, but we also needed 5. So I also added a 7805, so that I had a 12 volt rail and a 5 volt rail. So we only needed 5 volts for the Arduino. Everything else was the 12 volt line. You can see here we've got an LED driver and an LED. That's our headlight assembly. And then down here we just have an LED. That's the tail light. I'll get to that in a minute. And then we also have a relay. Now, moving on to the Arduino. What we have connected to the Arduino is a switch. That's our actual light switch. And then we have 2 brake buttons down here. Those are the ones in the brake levers. They're momentary switches. When you pull them, they make contact. So they're normally open switches? Not sure. So, the light switch. When the light switch is turned on, the Arduino is going to trigger this MOSFET, just trigger it, and current and voltage are going to be able to flow, and this LED is going to turn on to maximum brightness. The rear LED, when the switch is on, this is a PWM pin, so what it's going to do is, I've got it set to 50%, it's or 127, so for every second it's going to be switching on and off, and it's only going to be on for half a second. But it's going to be switching on and off, so it'll just look dimmer to us. I may cover PWM on another video. It's a bit hard to explain right now. So basically it's going to send a 50% signal, an analog signal, to this MOSFET, telling this LED to only be on half the time, or half the brightness. Now at the same time, the Arduino is also going to be polling these 2 switches constantly. And if either of these 2 switches are ever triggered, the Arduino is going to tell this transistor to just be full on, and this is going to go to full brightness, telling the drivers behind me that I'm slowing down. At the same time as it does that, it's also going to trigger this relay. This relay is connected to the original controller for the bike. This wire was originally just connected straight to one. Well, there's 2 of them, I only needed 1. And originally this wire that I'm using was connected to one of these buttons. So basically what we're doing is telling it that button's still there and it's been pushed. It's running 48 volts through this line. I can't remember which is positive, which is negative. Basically it's pulling 48 volts to ground. I didn't want to mess with that, so I just threw a relay across it. Now getting back to this switch, if this switch is actually off, my headlights aren't on, my taillight isn't on, but it's still constantly pulling these 2 switches, or buttons. Again, if either of these buttons are triggered, it's going to tell this MOSFET to go completely on, turning my taillight on to full brightness, or brake light. Again, telling the drivers behind me to not run me over. And that's pretty much it. Always remember to put a diode across any coils. and let's go take a look at the code. So taking a look at the code, the first thing we do, since we don't have to import anything, is we're going to declare 3 variables and set them all as 0. Button state 0 and 1 are going to be for our brake levers. Switch state is going to be for the switch, which turns the headlights and taillight on and off. Moving into our setup, we're taking pins 4, 5, and 8 and setting them all as output. Those are for our headlights, taillight, and relay. And then for pins 7, 11, and 12, we're setting them as input pull-ups. We're using a Pro Mini with an ATmega 328, so it has internal pull-ups, so I'm using them. Pin 7 is for the switch that turns the lights on and off, and then pin 11 and 12 are for the brake levers, which have the little momentary button in them. Looking at the loop here, the first thing we do is we take our 3 variables and we get values for them. We read the states of the 2 brake levers and store those in the corresponding values or variables, and then we take the state of the switch for the headlights and assign that to its variable. Oops. Next we take switch state and check if it's high or low. As we saw, it's a normally high switch, so when it's brought low, we want to turn everything on. So we analog write here. We analog write pin 5, the taillights, to 50% or 127. It's a PWM, so it's 0 to 255. And this is so that there's a noticeable difference when I actually pull the brake lever. We'll get to that in a minute. We also turn our headlight on just full, 100%. So we just use a digital write for that. Now we've got an else statement here, so if the switch is off or high, then we're going to turn the taillight completely off, and we're going to turn the headlights completely off. Next, we're going to check the state of our brake levers. They're, again, normally open. I can't remember. They're normally high. So, if button state 0 or button state 1 are triggered to low, what we want to do is digital write pin 8 high, which is our relay, and tell the controller to activate the electric assist braking, and then analog write pin 5, our taillight, to 100%, so that whether it's on or off, there's a noticeable difference, and the people behind me can see that I'm stopping. And then again, else, so if they're high, then make sure the relay's off, because we don't want the bike trying to brake when I don't want to brake. And that's it. Okay, so we finally have the headlights and taillights working. Turn the switch on, my headlights are on. My taillight is on. Got a bit of tinkering to do with the code, try and get the, maybe the resistors, try and get the taillight a little brighter. But as I pull the brakes, I don't know how well you can see that on camera. It gets brighter anyway. That's my brake light. And then if the lights are completely off, just the brake comes on when I pull the brake lever. You notice my keys aren't actually in the bike. Neither is my battery. The battery's just sitting there. As long as that kill switch is on. Oops. As long as that kill switch is on, my headlights work. If I kill the kill switch, they die. As you can see, they got a bit of a delay as I flip the switch now. But that's the Arduino booting up. But yeah. Alright guys, so that's been my e-bike headlight mod part 2. It's been a long time coming, had a lot of problems along the way, but it's finally here. I'm glad to bring it to you guys. Like, share, subscribe, leave a comment, dislike if you want. You know, all that YouTube stuff. Have a good one, guys.